Hello everyone. When we last left off, we were finishing up that example and starting to do congruent angles. So here we go. What are congruent angles? Congruent angles, just to get the gist of it, is when you have two different angles, but their measures are the same. So if blank, then the angles are congruent. And that's just if the measure of an angle is equal to the measure of another angle. So like in this case, it would be measure of angle A and measure of angle B. Then they are congruent. And once again, that is just saying that the measures are equal. So the 75s are the same number. Then you would say the angles are congruent. And the way you write that is angle A, and then you drew an equal sign, but with a tilde on top. Angle B. Like that. That is the congruent symbol. Basically, it's the same thing as saying that their measures are equal, but because angle A and angle B are different, they're in different locations, like this one, hey look, it's there, and this one, hey look, it's there. They're two different things, so you cannot say they're equal. Only that how big they are is equal, but the angles themselves are not equal because they're in different locations and therefore are different. So you can only say that they are congruent. So it's the shape version of equals. It's just shapes can't be equal to each other. So this leads us to an angle bisector. So an angle bisector is a ray, talking about rays again, that divides an angle into two equal parts. Or if you're not talking about measures and you're talking about shapes, you could put congruent. Either one of them works. You could say that this angle bisector right here, BD, that is a ray starting at B going to D. That angle bisector puts this into two equal measures. So this measure is equal to this measure. Or you could say this angle is congruent to this angle because they have the same shape. So in the diagram to the right, blank is an angle bisector. As I said, BD was an angle bisector. Therefore, and like I said, there's two things you can write here. I'm just going to do the congruent one so you can get used to it. To name this angle, remember, B is a vertex, so you have to go ABD. So angle ABD is congruent to DBC. There you go. I'll mention this. I didn't mention it in the other one, but please note this little symbol for angle. It is supposed to be like a horizontal line and then a line going up like that. So this bottom thing is supposed to be completely horizontal. Please do not confuse it with the greater than sign. Because you remember the greater than sign, both of those are angled. This is angled up and to the right. This is angled down and to the right. These are not the same. So please make sure when you're writing these, do not draw a less than sign. I don't know why I wrote greater. That's definitely a less than sign. Do not draw a less than sign. Make sure that this is a horizontal line, and then this one goes to the upper right. That is the angle symbol. Okay, I just wanted to mention that because otherwise it gets hard to read people's handwriting sometimes. Okay, so this angle right here, that is, oh, do I have another? Oh, I was hoping I had another highlighter color. Oh wait, maybe I do, maybe I do, maybe I do. That is congruent to this one. Oh, it doesn't work. Sadness. Anyways, it's congruent to that one right there, so. All right, perpendicular lines. Perpendicular lines are lines that intersect at a point and at that point it is a right angle. Now, dealing with other things we learn, if this is a right angle, that has to be a right angle because it makes up a line, and a line is 180 degrees. So if this is 90, that has to be 90. Then we also learn vertical angles are congruent. So if this is 90, that means this has to be a 90, and basically everything turns out to be 90. So all four of these are 90 degrees. But with perpendicular lines, all you have to do is say that it makes a right angle. So let's see, math word stuff. Two lines that intersect. Woohoo! Intersect just means they come together at a point, and then they hit at a right angle. So they say a right angle, but you know, if we're talking legit, it's 4 right angles. It just automatically implies that. The symbol for perpendicular is just a vertical line and then a horizontal line like that. You don't put a little tiny box, it's just a vertical and then underlined with a horizontal. It's supposed to mimic the fact that that's what this figure looks like right here. It is the vertical and then the horizontal, and you just don't put that part right there. And that's it. That's the symbol for perpendicular. So in the diagram to the right, what you would do is you would write m. It's just using lowercase m. As I said in the previous video, if you're talking lowercase, it's talking about a side or a length. So you would just say m, and it's a line m, is perpendicular to line L. Well, it just has an L thing, I guess, but whatever. It's m is perpendicular to L. If you felt like doing L perpendicular m, you can. That's fine. It's not it's not wrong. It's just a different way to write it. So you could do the L perpendicular m. Either one of those is fine. Okay. Perpendicular bisector is getting even more specific. Not only is it making a right angle when they intersect, but it is also taking a line segment. So instead of a line, it is a line segment, and it cuts it in half. So like if you draw a line segment, like you can draw a whole bunch of perpendiculars to it, right? This would be perpendicular, this would be perpendicular, this would be perpendicular. But a perpendicular bisector specifically would go to its midpoint and then make a right angle through it. So it is a perpendicular, but also a bisector. If you know those root words, bi means two, and sect means to cut. So it cuts it into two, is what's going on. So PQ here is cut in half. This length right here is equal to this length right here. That's what it's saying. So hopefully that makes sense. Let's see, a line, segment, or array, blank to a segment at its blank. Blank or array, I don't know, whatever. I think you guys can get it from what I was saying. In the diagram to the right, blank is the perpendicular bisector to blank. So you would have to do it in a certain order this time, because LM is cutting PQ in half. It is not saying that PQ is cutting LM in half. You have no idea about these lengths, right? You only can tell because of these little symbols that it's cut in half. So you cannot assume that LM is also cut in half. So you have to say that LM is the perpendicular bisector to PQ, because PQ is the one being cut in half. And then since these are line segments, it's a line segment that's being bisected. And LM, you can do a line or a segment. I'm just going to do the line. So this line, LM, is the perpendicular bisector to PQ, because PQ is the one being cut in half. I'm pretty sure this one is supposed to be midpoint, but I'm blanking on the top one. But that's all it is. It cuts it in half. Okay. So example 3. Let's get out my highlighter. Write another name for CBF. So I like this question because technically I don't even need this figure to answer that question. In order to name an angle, you first of all could check to see if there's only one angle, and oh heck no, there is not just one angle. So there's only one other way to name an angle. And if you recall, by necessity, the middle letter has to be the vertex. Meaning I already know that B is the vertex without looking at the figure. And the other way to name an angle is just backwards. But B has to be in the middle because it's the vertex. So instead of CBF, I could just do FBC. And that's just the answer right there. It's just B has to be in the middle and the letters go in opposite order. And now I can check if I felt like it. CBF. So we're talking about this right here, CBF. So yeah, FBC. It works out. And you can do the same thing for EBD if you felt like it. If you're more of a visual person, you'll probably just go straight to this. EBD is this right here. So you could say that the sides are BE and BD. BE and BD. Oops. BE and BD. And they have to be rays. Like that. So if you're a visual person, you can do that. BE, BD. If you're more of an algebra person, which you can do instead, is pretend we didn't do this. Once again, remember, B is the vertex. And whenever you go to a vertex and you go to a side, it's just you go to B and then you go to E, or you go from B and go to D. So you could do it like that. BE is one answer, and BD is another one. And you just draw the ray symbol on top. And you can see I just wrote the same thing twice. It just depends if you're visual or algebraic, doesn't matter. The next one you do have to look at the figure, ABC. ABC. Oh boy. ABC is just a line, so that makes it a straight angle. Give an example of an obtuse angle. I don't know. There's a couple of different answers here. I'm just going to go with EBD. That looks obtuse. So angle ABD. I'm sorry, EBD. I'm also seeing ABF is an obtuse angle. If you felt like doing that, ABF. It says just give an example, so I don't need to do more than one. I was just showing you that it doesn't matter as long as you put something that's obtuse. Name two congruent angles. Well, let's see. This is cut in half, but that has nothing to do with angles. I see no numbers here. The only thing that, because congruent means they have equal measure, but it doesn't flat out tell you any measures, right? It doesn't say 30 degrees or anything like that. The closest they get to is this right angle here, which implies 90 degrees. So the only thing I can really talk about is CBD. So CBD is congruent to another right angle, and it looks like that angle is going to be ABD. There you go. So two congruent angles, CBD and ABD. They are both right angles by necessity. And then name a perpendicular bisector. Well, it looks like AC is being bisected because it has these things right here. So that means this is the actual bisector. So it's wanting whatever this is as the bisector. And the only 2 points on that line is D and B. So in this one, it does not matter. You can do BD or DB. So I'll just write BD. That line is well, it is making this. I guess it's not technically what's asking. It's just saying name a perpendicular bisector, but I'm still gonna write it this way because I like it. So BD is the bisector, or the is perpendicular to AC, and this is just a line segment. So I'm not gonna put the arrows, but it is a perpendicular bisector. Perpendicular bisector. Cool. All right, so once again, I recommend you pausing, trying this, and then I'll quickly go over the answers. So go ahead and do that. All right, name the vertex of angle 2. This is angle 2, so the vertex is going to be this, which is T. It is just the letter T, because the vertex is just a point. You do not name an angle. The sides of 4, so this is 4. So you have to start with the vertex and go outwards. So TW and TZ, TW, TZ, TW, TZ, and sides are rays. Start at the vertex. Another name for angle 3. Well, angle, the vertex is T, so T has to be in the middle. And you can do either UZ or ZU. It doesn't matter. Those are the two sides, so UZ or ZU. I'll just do UZ. So UTZ. Angle 1, YTX. Classify YTW, so it's talking about whether it is, a right angle or obtuse, acute kind of stuff. So YTW, YTW, so YTW, that looks like it's 90 degrees because of that little tiny mark right there, so that's right angle. Did you get that right? YTU, YTU, this one right here, that is more than 90 degrees. This one's easier if you just kind of look at it. Like if you turn it a little bit this way, 90 degrees would be this much. So this is definitely more than 90 degrees. So it's obtuse. XTU, XTU, this is XTU right here. That is less than 90 degrees. It's always comparing to 90 degrees, so, sometimes you can just visually see, oh yeah, it's less than 90 degrees. So it's got to be acute. Oh, how much do you want to bet the next one is straight, because it's the only one we haven't done yet? Let's find out. WTX, WTX. Hey, look at that. It makes a line, which makes it a straight angle. Woohoo. Name 2 perpendicular lines. The only right angle we have is this one, so it's got to be this and that. So YZ and WX, perpendicular sign in the middle, and their lines. And then it says name an angle bisector. So remember, that means the angle is cut in half. So it's talking about this part right here. So you would need to name these 2 angles. Luckily, it labeled it as angle 2 and 3/4, so we don't have to do the triple letters or anything. Actually, it's asking for what the bisector is, so it's not even asking what the angles are. The bisector is what is the ray that is cutting it in half, and that would be TU. So the answer is TU as a ray. Okay, there you go. That is this page. Still have 2 more videos I think I'm going to be making, but whatever. That's this one. We're gaining up on 20 minutes, so I'm going to stop it, obviously. Hope it's helping.